The story of the giants of the seas began some 55 million years ago, shortly after the disappearance of the dinosaurs. A period of global warming had a major impact on the planet, and sea levels rose. Some land mammals moved towards the water. Among them were the ancestors of the cetaceans, including whales, dolphins, orcas, and toothed whales, which still walked on all fours and hunted on the shoreline. Gradually, they ventured into the shallow waters before beginning to swim to catch their prey. 10 million years later, their descendants finally quit terra firma for good, taking to the oceans. Swimming proved a wonderfully effective strategy, and with the water supporting their body weight, they evolved into titans. That was how the giants of the seas evolved. To go in search of these ocean-dwelling behemoths, we will follow François Serrano, an oceanographer, a former companion of Jacques Cousteau, and a tireless explorer and defender of the marine environment. François will dive alongside the largest animals on the planet in an effort to pierce the mystery of their incredible success.
When the land-based ancestors of these cetaceans returned to the seas 55 million years ago, they had no chance. They were entering a hostile environment. They had to breathe. They had to hide in an environment where there was nowhere to hide. In the deep blue sea, there are no hiding places. They had to give birth in an environment where the offspring had to be able to breathe right away. Yet, despite all these obstacles, they thrived. We've only scratched the surface of these discoveries because we have yet to decipher their language. And that language is much more complex than we previously thought.
The Bahamas, in the Caribbean Ocean, is a collection of some 700 islands, including the Bimini Islands, which are the closest to Florida. The shallow, sparkling seas here are home to two species of dolphin, the Atlantic spotted dolphin and the Tursiops, or bottlenose dolphin. It is also home to the Dolphin Communication Project, run by Kelly Melillo. She has spent the last 15 years studying the dolphins of Bimini. She is going to take François Serrano and his bosom buddy, underwater cameraman René Euzet, to meet them.
It's really good when it works. The thing is to get it to work.
Thanks, René. Thanks a lot.
Don't worry, you won't lose the dolphins or the boat because there's no mist.
François wants to dive with the dolphins and try to understand how they use sounds to see the world around them and to communicate. Kelly knows these creatures better than anyone. Thanks to photos taken from the surface, she has identified 102 spotted and 70 bottlenose dolphins. They are sedentary creatures and will spend their whole lives in and around Bimini.
Okay, so what do you like to show me the most important?
When you come out with us, Francois, I hope you see everything. I hope you see things.
I just want to see them playing together.
They play a lot. You also might see them echolocate just by watching their head scan. So as they come to investigate you or your fins, if they turn their head, they're checking you out. You might hear certain frequencies of the echolocation. If it's a bottlenose dolphin, you might feel it. I can feel when a bottlenose dolphin is behind me echolocating on my head. But the spot is, it takes 3 or 4 of them all at once before I can sense it in my whole body.
But to see and hear the dolphins, you still have to find them.
What does it say up front?
We can't see them anymore.
Have they gone?
This is when René's experience of underwater filming becomes useful.
We'll look in a couple of minutes. The most important thing is that they aren't too far from the boat. Over there. There, just behind. There. I wasn't wrong after all. They're just behind. You can see them breathing. There's a young one.
There's the little one.
Yes, it's the young one. He can't hold his breath as long as the adults can. Can you turn it off, Jean-Christophe?
François takes a hydrophone with him, an underwater microphone, and takes a dive into a world of sounds. The first to come over are two spotted dolphins that are swimming together. François immediately recognizes the echolocation clicks being sent his way to identify him, and the whistles the dolphins use to communicate with one another. But it's also their body language that attracts François' attention. Their need to be in contact and to touch each other. What subtle links are formed between them? What do they tell each other through these gentle caresses? No doubt those clicks have a special meaning for them. And the sounds mingle, buzzes, clicks, whistles, and chirps, and probably many more sounds that we can't even hear because the frequencies they use are inaudible to us.
Whether they are sperm whales, dolphins, other whale species, or orcas, each time we meet these cetaceans, we are witness to the incredible complexity of their societies. And where you have a complex society, you naturally have a complex communication system. And we've seen that they communicate through their bodies, by touching, through their gaze, and of course through sounds. In a marine environment where sounds move 4.5 times faster than they do in air, in an environment where it's hard to see, communication through sound is essential.
Whale song, sperm whale singing, dolphin whistling. What are these giants saying through these enigmatic sounds? This is a question François has been confronted with during all those years he worked alongside Jacques Cousteau. But today still, it remains a fascinating mystery to him. From the outside, we can only see and hear these bodies striking the surface with all their force. These humpbacked whales weigh 30 tons, and the sound reverberates through the ocean, carried for miles. These sperm whales' tails also strike the waves. and these acrobatic dolphins. These cetaceans use every inch of their bodies and every inch of the sea to make noises, signals sent to other creatures. Their fellow dolphins, friends, partners, and rivals. Nobody really knows. And beneath the surface, the sound ecosystem is as full as the ocean looks empty. And yet, amid this brouhaha, every creature has its own sound niche. Each one recognizes their partner or their enemy. Two creatures can be several miles apart and yet stay together, thanks to sound. There are links between them about which we know nothing, and of which we cannot even catch a glimpse. All we can do is appreciate this concert in the oceans that fascinates us with its incredible strangeness. And in this concert, the most famous soloist is the male humpback whale. Every winter, the humpback whales come to the tropical waters to give birth. During this season of love, only the males sing. They stay still for long periods, as if suspended in the water. They vocalize with their mouths closed without releasing the slightest air bubble. They hum for hours their endless song. Is it to attract a female? Is it a song of happiness? Or a war cry? The truth is that nobody really knows. The males gather in their numbers in the tropical seas, and their songs travel through the water over tens of miles. Even unborn calves in their mother's wombs can hear the sounds. His mother will never be able to teach him because she can't sing. He will learn by impregnation as he bathes in this sound ambiance. The songs are so powerful that they have monopolized the attention of scientists and have drowned out all the other songs. As such, for a long time, we believed there were no sounds exchanged between mother and baby. However, the maternal relationship is central to the lives of humpbacked whales. It is very unlikely that sound plays no role. Oliver Adam, doctor of bioacoustics, was the first to have recorded sound exchanges between mother and her calf. This was a veritable scientific discovery. Today, he is on the island of Rurutu in the south of the Austral Islands in French Polynesia. After a long voyage of several thousand miles from Antarctica, the mother humpback whales have found refuge in these calm waters and have given birth to their young.
Surface.
There are fewer males, and this is a chance for Olivier Adam to approach the females and record their sounds, as well as those of their calves. we hear the low-frequency sounds and the pulsated sound of the mother, as well as the short, acute whistling of the calf.
What we noticed compared to the male song is that the sounds emitted by the females are much less frequent and are relatively simple for the calf. It's more like a whistle with two main characteristics. The first is that they're very short. And secondly, they're fairly badly constructed. We have the impression that they can't hold their note, as if they're discovering their vocal system, which is like managing their vocal cords, the tension of the vocal cords, and managing to stabilize a note like our children do when they start to sing, and they have difficulty stabilizing. It's like the difference between a professional singer and an amateur.
Since he recorded these first exchanges, Olivier Adam has been trying to unravel the secrets. To him, the mother's whistling allows her to warn her calf in case of danger. It can also be used to call her calf back when it moves too far away and out of sight. And when they come together, the sounds of each must signify all the affection and tenderness they have for one another, making each other feel good and comforted. From communication between mother and calf to the songs of the males, sound is a major part of all the links that tie whales together: attachment, seduction, or rivalry.
What you need to understand is that acoustics are vital for cetaceans. They use sound for everything: reproduction, social interactions, looking for food, localization, defining their environment, and characterizing their environment. They use sound for everything they do in their lives. To me, it's inconceivable that it's limited simply to communication. I'd go so far as to say that if they are such specialists in sound, and if they use them in that way, in a global way across their lives, one might imagine also that it is a language.
Language. The word is out. And if we are talking about language, does that mean cetaceans, and dolphins in particular, use words? Back in Bimini in the Bahamas, Francois has welcomed on board Dr. Kathleen Dudzinski, founder of the Dolphin Communication Project. She brings 25 years of experience with different types of dolphins that she has studied around the world. Who better than she to explore this vast notion of language?
In my studies of dolphins, I've found that they use a variety of signals to share information. They may use sounds, whistles and clicks. They may use gestures, postures, how they approach one another for angles, and a variety of different behaviors. It's more what I would call a vocabulary of a variety of signals, not really a language or words.
Now all that's missing is the dolphins. But people have no idea of how empty the ocean is. Aside from a few oases of life around reefs, it's deserted. And sometimes you can find yourself alone. With our limited human senses, we can't see much and can't hear much either. The bottom of this underwater desert is strangely covered with craters. Francois has discovered dozens of them, that make it look like a lunar landscape. What strange creature could have dug these craters in the sand? The few fish that are here, pearly razorfish, are not easily approachable and hide immediately under the sand. They leave no trace behind, not a wrinkle, even less a crater. Then suddenly, we hear crackling and clicks. At first, they are almost imperceptible, but then they seem closer, announcing the arrival of some bottlenose dolphins. It's they that are responsible for these strange lunar shapes. As Francois watches, the dolphins perform a strange ballet, the logic behind which is revealed when one of the dolphins scares out one of the fish Francois spotted hiding in the sand. The dolphins are hunting by sound. They emit very rapid pulses of noise in the direction of the sand and use the echo sent back to create a sound image. This is echolocation, a sense that works much like sonar, or rather like an ultrasound that allows them to see through or under the sand. And this is how they spot the fish hiding there, force them out, and gobble them up. Thanks to this sixth sense that we humans lack, they can see beneath the surface of things. Unlike sperm whales that can dive for more than an hour, dolphins must surface to breathe every 3 minutes, and interrupted back and forth between the surface and the depths. Now it's Kathleen's turn to go underwater. She free dives with a face mask and snorkel. She takes a deep breath to observe close up a mother and its baby that are swimming around Francois. The baby stays right by its mother's side, almost glued to her. It doesn't miss a single move. Because this technique for crater hunting is not innate or instinctive. It has to be learned.
That was really cool. Really cool. There were several adult dolphins crater feeding, and there was a mom and calf, and it looked like the calf was hanging with the mom, maybe trying to figure out what to do. It's very cool. Whenever I record dolphins underwater, whenever I'm studying them, I sort of feel like two people or a split personality underwater. I feel like the scientist who has to document everything, and there's a passion there. But then I also feel sort of like a kid, where I get to watch what's going on between these different individuals in a completely foreign environment. The observations today were fantastic. It was the longest time I've ever been in the water with crater feeding bottlenose dolphins. I did hear echolocation when they were foraging, and then I heard whistles and maybe a few other sounds. And so that's another aspect of their behavior. How do they communicate when they're foraging? And they're foraging individually or by themselves, but all in one area. So how do they coordinate that?
Francois and Renee have stayed below and watch as the other dolphins arrive, as if someone sounded a rallying call. They notice a strange and powerful sound that has nothing to do with echolocation. Is it a rallying cry for the dolphins, or a call to join the feast? More and more dolphins join in, hunting and eating.
Oh, you must have seen that.
Very cool.
Mais alors, à côté, ils se fichent de toi. C'est eating, they are playful, they play with you, they hunt, they play. The mother, the calf, plenty of female.
It comes up. It turns around, and then suddenly it brings the fish out and then snaps it up. Magnificent.
They're making a noise I've never heard before.
That's how I recognize them.
There was a whistling that you usually hear, but then there was a noise a bit like a pump. You know, like a toilet pump on a ship.
We have heard a strange sound and like a boom, boom. When the mother and the calf meet another dolphin, and René has recorded it with his camera.
I'd love to hear the sound, because
It's strange. I don't know what kind of.
Nous, on entend beaucoup de sons.
We hear a lot of sounds, and I think that when we listen back to what René recorded underwater, we'll be able to differentiate between these geolocation sounds and perhaps the sounds of the different dolphins eating beside one another, coming together and starting to play. But I think we'll have to analyze it from the images.
Yesterday, when diving with René with a bottlenose, we witnessed their critter feeding, and we listened a strange sound. Listen. That is what we saw yesterday, and this strange sound.
Yes. Those are bottlenose dolphin bray calls. We've documented them here before on when bottlenose dolphins are feeding. And colleagues of mine have recorded bray calls in the Seto estuary in Portugal and in the Moray Firth in the UK. And I've recorded them off New Jersey. And they seem to be related to bottlenose dolphins feeding. Whether they may be a call used to indicate the arousal or to call conspecifics to say, hey, I found fish, we're not sure. Another hypothesis that Vincent Yannick proposed is that they're maybe used to sort of disorient prey when they're hunting, maybe to stun the prey a little bit so that they're easier to catch. Here, we're actually able to record the behavior and the audio so we can start to get an idea of how they might be correlated.
And did you hear them when they are not feeding?
We have not heard those calls when they're not feeding, no.
I am remembering that years ago when diving in South Africa, you know, in the sardine run, when dolphins hunt sardine, it seems to me that I heard this kind of sound. That's a woof, woof, you know, quite very similar.
These mysterious calls are no doubt one of the keys to dolphin communication. How do they call out to one another in this world in which it is so difficult to see? But we know so little about life in these vast oceans, and the time we get to study wild dolphins is so limited. It would take years of study in order to understand them fully, and because of that, some scientists are focusing their efforts on domesticated dolphins that have lived in captivity for generations. Francois goes to Key Largo in Florida to meet Professor Stan Kuzai, who is studying communication between dolphins in captivity.
One of the things that we're trying to do is figure out how dolphins make sense of their world. And so communication is a very important part of that. We look at the sounds that they make, look at the way that they touch each other. They do a lot of peck rubbing like this. You've seen that.
I've seen that.
You've seen that many times.
Yes.
Yeah, I'm sure you have. And so we're trying to tease all that apart. It's sometimes frustrating because it's not simple because their communication is flexible. It's not like vervet monkeys where they have an alarm call for an eagle, alarm call for a lion, and so on.
And you told me that you are focusing on research signatures, that each dolphin have to name itself and to call another one.
Think about it. One possibility is that every dolphin would use the same whistle to call the calf back. There could have been, evolutionarily, there could have been a sound which came to mean come. Yeah. Right. And so that could have happened, but that did not happen. What happened is each mother uses a sequence of sounds which incorporates the signature whistle to call her calf back.
So each dolphin can name itself, and
it's
a
lot
more
like,
difficult.
Well, but I think it's a lot like a name. Okay? We don't know if it really functions as a name yet, but for the sake of simplicity, I think that's the best way to think about it.
Yeah, yeah.
All right, go ahead and send again, JP.
To demonstrate this signature sound, Stan suggests an experiment in which several mothers and their calves are put in one of the pools at the center.
All right, sending BB.
One of the calves is sent to the other end of the pool.
As soon as she gets there, receiver, and then we'll call. Very good. Heads up for other dolphins. Very good. Trying calling.
Then, using a hand signal, they ask the mother to bring the calf back. Either she can go fetch it, or she can call it by its name. And 90% of the time, she calls it back without moving, and the calf comes back to her.
She's turning. Orienting towards the mom. She's on her way back. And she's back. Success. Awesome.
Yay.
This proves the importance of sounds and vocal communication amongst dolphins. But that's not all. During these experiments, Stan and his team record the sounds emitted by the mother to call her calf. And they have realized that the mother always begins her call with the same whistle. And in carrying out the same experiment with other dolphins, they've noticed that each mother begins with her own whistle, a signature whistle that seems to describe her. This signature indicates which dolphin is calling when they cannot be seen. Does this represent the discovery of a first word? The first word in the dolphin dictionary?
I don't know if we'll have a dictionary. I think we'll have a better understanding about what these signals mean. The reason I'm trying to avoid use dictionary is I think it's a mistake to try to understand dolphin communication in human terms. I think what we need to do is try and understand it in terms of what they need to communicate and what information is important to them.
Hand signal.
Farther south in Mexico, Jack Casowitz's research has taken him in a different direction. A self-taught, passionate, out-of-the-ordinary scientist, he had a hunch. What if dolphins didn't use words to communicate, but instead used sound images through their sixth sense, that of echolocation?
Are they born there?
These were born here, yes, sir. And actually, that one I was here when he was born. And when he was first born, I recorded the sounds just as he was born. And dolphins, different than humans, have a lot of vocal structure when they're first born. They can echolocate. They have a signature whistle. I mean, Mama does most of the talking, but they still have a lot of it.
So how did you get the idea that dolphins communicate not by sound as words, but as hologram or images?
Well, for me, when I was very young, I had something called attention deficit disorder, and I kind of just saw in pictures. I didn't think like regular kids. I really saw in pictures. And when I played music, like I played drums. When I played drums, I saw the colors, I saw music, I could see it. And as I began to look at these guys, I realized that they are really in a world of sound. I realized that, well, maybe the traditional idea of them using words is a very good human term,
yes,
but maybe it's a whole different system. And I said, well, what if their system was like mine? And I saw these cymatic patterns that they were made by a man named Chladni, and Chladni would put a plate and he'd put some stuff on it and he'd put sound below it and it would make these interesting. And I said, well, what if I took, this is how it started, what if I took a dolphin sound and did the same thing and put it into a Chladni plate?
Chladni patterns are named after a German physician who lived in the late 18th century. By putting a plate on the sand and emitting a precise sound, Chladni showed that the amplitude of the vibration is not equal everywhere and results in shapes being drawn. Thanks to the sand, you can see the waves that the sound prints on the plate. And if you change the sound, the shape changes. Chladni's experiments allow us to see sounds. You can even reproduce it with a simple drop of water.
That looks good. So now I'm going to go down and we're going to begin to use the hydrophone. You can hear them here.
Jack's idea is to present different objects to the dolphin for it to scan. In the water, he will record the vibrations from the sounds emitted by the dolphin, and in particular, from the echo the object sends it.
Get your hydrophones in position like we did. Remember, you have to hold them in front of the object. Let's bring them in. Do it twice.
Jack starts by showing the dolphins a cross. The sound vibrations in the water are only supposed to draw concentric circles. But to the surprise of the specialists, Jack discovers straight lines. And by making the image denser, we can even make out the shapes of the objects. A cross. A cube. Jack does more experiments with all kinds of objects, more or less incongruous. And even with a human being, whose shape is revealed in the dolphin's echolocalization. Jack has managed to visualize what the dolphins perceive using sounds. This is a major breakthrough.
All right, everybody in the water.
But Jack wants to push the experiment even farther. In another pool, he broadcasts the echolocalization sounds he recorded with other dolphins. He wants to see if when the echolocalization sounds of an object is broadcast, the dolphin will bring back the specific object, in this case, the cross.
You guys ready? Yeah. Throw your objects out.
Where are they?
1, 2, 3, go. Okay, that's a positive.
It's a very promising line of inquiry. But we're still a long way away from knowing if it will stand up because as yet, there is no evidence that dolphins have the physiological capacity to re-emit sounds sent by objects, as Jack did with his equipment. If it were the case, one could say that at least part of their communication involves these sound images. Whatever the case, Jack's experiment has at least one benefit. It has allowed us to enter the world of the dolphins. When we try to understand dolphins and their communication, we must not think in terms of human language. We need to think in dolphin. What senses do they use? What are their communication needs in their world, in their society?
Today, thanks to equipment that enables us to record underwater sounds, we are beginning to grasp the extraordinary variety of sounds dolphins use to communicate. They are able to perform ultrasound examinations of their environment and perhaps are able to send these ultrasounds to other dolphins. Perhaps this is a form of communication that allows them to go beyond words and provide an image of what they have seen. And we always tend to associate the sounds we hear, the whistles emitted by the dolphins, with words we know. Trying to find a Rosetta Stone that would allow us to see the link between a whistle and something that corresponds to our own language. And we ask, do dolphins speak like us? Do they have a language like us, a dictionary like us, and intelligence like we do? It's stupid, and we aren't asking the right questions. The question isn't whether dolphins speak like us, or if they're intelligent. It's about trying to understand how they are intelligent and how they communicate in their own world.
Back in the Bahamas, Francois, who has always fought against the practice of keeping dolphins in captivity, is glad to leave them behind. He will soon be returning to visit wild and free dolphins in their natural habitat.
Ready, Francois?
Yes, yes.
Okay, they're over there. They're coming. We're going to get into the water slowly because I don't want to scare them, okay? Can you hand me the camera? Francois, let's go.
It is difficult to see any connection between dolphins in captivity, confined for several generations in pools in Mexico, Florida, and elsewhere, and these acrobatic, wild, and free creatures. They understand the scope of the ocean, the storms, predators, their prey, and all the complexity of social relationships, friendships, rivalries, and alliances. Their communication naturally reflects the ever-changing diversity and immense nature of their world, where one can spread out over miles, where everything is open.
We try to imagine their world when we don't know how they communicate and we don't understand their senses. It's incredible. We don't even have the vocabulary to describe what they are capable of. We invent words, clicks and clacks, a whole heap of poor imitations of what they manage to do. And we try, like blind people, to describe the world in which the sighted live. You can't even imagine it. They live in another world. They are like aliens.
Aliens. To understand them, we have to think about a different type of encounter. Cetaceans don't have the same needs as ours. They don't have the same desires. They live in a world where property and accumulating things have no meaning, where space has no limits, where time goes by in a perpetual present. We need to forget our references and leave our preconceived notions behind. We need to lose ourselves in their world. And then, maybe we will discover what they are trying to express is of a different order. Something emotional and social.